Welcome everyone to another session Data with Nikk. I'm really excited today to talk about the Lakehouse concept, a new data concept from this decade with a focus on saving, processing, and serving data efficiently. For me, it also means to say goodbye to data warehouse, the concept which started being developed in the 80s with a focus on reporting and BI and using SQL language. But what about machine learning? I don't want to copy and query data from a data warehouse. I want to use Python. And also, how about unstructured data for machine learning? And also nowadays, generative AI. And also, what about the high cost which we nowadays have on data warehouses due to the huge increase of data amounts we have in our data landscape? That's where the Lakehouse concept comes in, which is adopting the governance features for data warehouses with the cheap cloud storage we have nowadays. Really, this concept really ramped up the last few years, and a lot of companies are adopting to lakehouses. That's why today we're gonna take a look what a lakehouse is and how it really looks in detail conceptually. So let's get started.
So what is a lakehouse in a nutshell? As said, it's a combination of a data warehouse and data lake, and that's the lakehouse. That's also where the name is coming from. House plus lake makes lakehouse. And in a nutshell, if you want to develop an analytical a data warehouse on a storage account, we need some kind of file format based it's open source, which is capable of analytical queries, and that's something like Parquet, like OCR, and that's on top what it builds on. We don't want to develop any new formats for this concept. And we want first-class support for machine learning, but also state-of-the-art SQL performance. And that's the most important topics. Let's look a little bit onto the history. I said in the 80s we had the data warehouses, and what we did there is we had our transactional databases where we saved all the data, and then we ETL them to a data warehouse, like this big parallelized infrastructure, which had the purpose for analytics and data instance, or analytical queries basically. And we had one central place for all the data. And so, well, the benefit of having a central place is you can also have a central access control, governance, asset, meaning atomicity, consistency, isolation, durability, and provide this data reliability and integrity. So an example is an ETL workflow breaks halfway. You don't want half of your data in the data warehouse. You want the ETL workflow completed fully. So it just doesn't save half of the data. It just lets the ETL workflow fail and then repeat it to have this reliability in the process. So that's what ACID is, for instance, for. But the disadvantages of this is also like that the coupling of compute and storage was quite huge. And the warehouses were also like defined based on the peak performance, and you couldn't like easily scale down or scale up whenever needed. And the coupling also meant higher costs for storage and data warehouses. And then we came also up that we want to do now machine learning, and we had unstructured or semi-structured data like pictures and JSONs, and that's where the data warehouse wasn't really capable to do that. But just to say, those warehouses are still existing nowadays in companies, and the government's really a point which really brings a benefit of the data warehouses and having them despite the higher cost. But now with the big increase of data, those costs really go further up. But what happened then? Low cost storages came. So for instance, with the Hadoop file system, with easier access and higher flexibility. And later on around the 2015s, also cheaper cloud storages like the Azure Data Lake storage came, which is really capable to save petadata and even more on those storages, and also provided additional features like backup concept, archiving, geo-replication for quite easy prices and easily to set up. And what we did now is we moved all the data, structured, semi-structured, unstructured, into a data lake, and a subset of the data we process further into the data warehouse, which was needed for analytical purposes, BI reporting, etc. And well, part of the data we also needed for machine learning. So what's were the capabilities now? We had a data lake, so we could save them in the file format, which was readable by those data frame APIs, which usually were needed for the machine learning libraries like XGBoost, sklearn, etc. They wanted some tabular data, but not from the database, but rather from flat file like Parquet. And what we also did is and that's actually the bad side, now that we want to do machine learning, we either had the data already in the data lake from the pre-ETL process, or we had to copy the data from a data warehouse down to a data lake um, to do our machine learning. And that means that we had a lot of duplication of data. This meant also that the cost might even increase, and then it was hard to govern the data and ensure the quality on the data lake because it really became like a data spamp. And it sounded and looked really a little bit chaotic. Some data is there on the data lake, then a subset on the data warehouse. Then we had out of sync issues because the same state of all the data was not always on both places. And this created complexity, bugs, and so on. And well, that's where the data lakehouse concepts came in. So we built generally, first of all, everything on top of a data lake. So instead of having two places, data warehouse and data lake, we use only data lake. And it supports transactional support for ETL workloads with an open format like Parquet. I think we mentioned it already too often now. And supports streaming and batch processing. This was also really good. It's really good benefit. But we also need BI support. So Power BI, for instance, or other reporting tools, they usually like SQL, and you also want an SQL-like interface for all those people who worked the past decades with SQL databases. And also you need some kind of interface like JDBC and a powerful engine. So the Spark engine, for instance, um, can can be used. And then we also wanted support for machine learning. So one place for all the workloads. And base we use open standards because we don't want to redevelop the whole world. And Parquet is an open standard. JDBC is an open standard. And well, and then we have all those further features which in data warehouses we like ACID, the governance. We now have like some kind of easier place to govern our data and having some audit logs. We might need some indexing for faster and more efficient queries. And how about data versioning? Can we version our data like in the different stages it develops? So that's something data warehouses, for instance, don't have. And really important, a separation of storage and compute. How beautiful would it be if I have all my data in one place and then I ramp up compute only when I want to query the data for a report and only on the scale which I really need, which can save a lot of cost. And Parquet, for instance, is supporting structured, semi-structured, and unstructured data, and that's at the end what we also want to have, like one place for all the data. So that means we come to three components of the lakehouse. So we have a metadata layer. So basically like a meta log file, for instance, where transactional data for data integrity are saved and also allowing batch and stream processing. And we also want the schema enforcement. So like we had in the data warehouse, we want the schema to be enforced so that we can realize if any changes in our schema happen to be able to govern it. We also want audit logs and versioning, indexing, a transaction history. And then we're coming to an SQL API. So I said we want to have it really performant. So first of all, we need an interface which can deal with those metadata layer on top. And well, what Databricks, for instance, did is they developed some SSD caching, which well saves the data closer to the query. Um, and partially decompress the data, and well, it generally faster storage if you save the data in a SSD. And so we also want to leverage statistics as data warehouses did. So if you have statistics, you can use file skipping or predicate pushdown to load only the data which is needed, and this speeds up also your queries. So that's what data warehouse, for instance, also did, and that's what also Parquet partly partly did. And then we want a really powerful engine. So we want to have a data warehouse performance like, but just based on a storage account. And the good thing is like there was a concept developed already in the meantime, like a Hive Metastore. So it built up a data warehouse first based on Hadoop and based on Spark later on. And it was in the past connectable to Parquet. So you had a SQL-like engine on top of it, and that's something we could also leverage now for the Lakehouse approach. Using a Spark engine, Databricks even developed a more powerful one coded by C++ in the background, and also use the open source format JDBC. And in parallel, we still have our stream of data frame APIs like pandas, which can be leveraged then by different machine learning modules like XGBoost, PyTorch, etc. And that's the major concepts of a lakehouse concept. But now you wonder, we don't want to create a new file format. And I already said we want to leverage what's already available there, open source. And that's what pretty much at the same time three storage frameworks did to serve this metadata layer, which can be then leveraged. So on the one hand, we have Data Lake, created by Databricks 2017, also in 2017 by Netflix created Iceberg, and Apache Hudi was even available a little bit earlier, created by Yuba. And those three formats have three things together at the same time. So first of all, they are open source. So Iceberg and Hudi, or Apache Hudi, is from the Apache Software Foundation, and Linux Foundation is supporting Delta Lake in this case. And then we have Parquet, Apache Parquet to say, also an open file format. And then we have this metadata layer on top, and that's pretty much the structure is quite similar for those three files. So it's also surprising that three files are now similarly used in the data landscape, but we're gonna focus in the next episode on Delta Lake, because I mean, one reason is also it showed like quite well performance, and as I'm a Databricks guy, or working a lot of Databricks, I might also be a little bit leveraged to rather use Delta Lake. So one other topic which came up with this Lakehouse architecture is the so-called Medallion Architecture. So it's pretty much a design pattern, how to logically now organize your data to also have like this governance and monitoring on top of your data. So you can call them now bronze, silver, gold as they did. We, for instance, my company, we call them differently. But pretty much a bronze layer is where you push your raw data. Well, in raw format, but best in the Delta or Iceberg format, whatever you're going to decide. And you want to minimize your transformations because you want to use this data for reprocess or exploration of your raw system if you're pushing the data. And then in the silver layer, you do mainly filtering and cleaning, maybe some exploding of your data if you have JSONs so that they're more tabular. And maybe you also enrich the data or quent the data with some meta tables, etc. And then the gold layer are really purpose and use built tables. They could be actual tables, but they can also be just views on top of it. And this includes aggregations, join, report optimal tables, like using some indexing approaches for a specific use case, filter out columns which are not actually needed to improve their performance, etc. And with that, let's sum up what we learned today. So we really learned that the lakehouse concept is a concept which really now seems to be state of the art and combines the best of data warehouse and data lakes. in one single place. So we have schema management and governance, asset transactions. We can use operations like inserts, deletes, and updates. It's something actually I forgot to mention before, which is also important. And we have SQL support, but also machine learning support, and we can leverage ETLs for streaming and batch processing. Also regarding the file structure, we are not restricted anymore. We can use structured, semi-structured, and unstructured data. And with that, I hope you enjoyed the introduction to the Lakehouse. If you want to stay tuned for the next episodes, deep diving into Delta Lake, please subscribe below. And well, see you soon in the next episodes, deep diving into Delta Lake and really understand how to leverage this technology for your ETL processes. Goodbye.